Hello. All right, let's get started here. Who wanted to talk about try, catch, and finally? Or actually, let's do this. Does anybody else have anything else they're bringing? Why is this not working? Does anybody else want to talk about anything else? I can. It was a suggestion. I'm happy to talk about it. What is caching? Okay.
Every time I install like a package.json, the package-lock file always gets created.
Yeah.
Do I need it?
Did you Google package lock file?
I did. It says I have to like commit it.
Yeah. Yeah.
But it doesn't go away.
Yeah, you don't want it to go away.
Need it?
Yeah.
It never popped up like before.
I know, it's new. Yeah. All right, we'll talk about it. What is package lock? Okay. Anything else? No? Cool. All right, let's talk about try, catch, and finally. Who was asking about this? Try, catch? Okay. Cool. So let's see. The reason we need try and catch is so that our program can have errors and we can rescue from those errors. So if we just had a simple function that was just going to be our classic add function, and we want to be able to run this function, but if there's a problem, we want to be able to rescue from that problem. So let's see if we can make that happen. So if we had, I don't know, is this going to be a problem? I doubt this is going to throw an error. No. Let's console log this. Cool. So let's say we had a problem actually in our function where I have a syntax error, right? If I run this, it throws an error. It throws a reference error because I'm referencing a variable that doesn't exist, right? This is just an example of an error. There could be all kinds of other errors, right? So let's say we have a scenario where we want to go through and let's say we're adding a bunch of sets of numbers. So we're going to say numbers for each set. We're going to say console log add of the first number and the second number, right? Let's say, what did I do? Thanks. Cool. So we're going to get an error the first time, right? Because add is broken, right? So if we wanted to make sure we could rescue from this, it's actually, doing this in an array is not really what I'm talking about. Let's just say we had, this was like an HTTP request or something that we needed to respond to, right? So let's just call this handle HTTP request as an example of handling that, right? So we're going to do this work where we add two numbers together, but we want to make sure that even if this completely fails for some catastrophic reason that we're still able to respond to our request, right? Even if it's an error, right? So if we've got this, request and response object which don't actually exist, and we want to be able to say response.send, it worked versus there was an error, right? We want to be able to send one of those two responses. So instead of using send, I'm just going to use return here for that, just for this example, right? So we want to be able to return either it worked, maybe plus the result, or there was an error, right? So if we run this the way that it is, the happy path, the ideal path is that we just do add the numbers and then return it worked, maybe we'll send the result back, right? Something like that, right? So, but when we run this, there's an error. Const, thank you. There's an error, different one. Oh, I never called handle HTTP request. Great. So now we still get this reference error, right? Because this function's it's completely broken, right? So one way we can do this is say try to do these things. Try to get the result and say that it worked. Catch if there's an error, and if there's an error, we're just going to return, you know, there was an error, and maybe the error message. Right? So if we look at the response of this, we'll see there was an error. C is not defined, right? But if our function worked correctly, we would get it worked, result is 15, right? So this is a synchronous way for us to run a function and have it raise an error telling us that something's wrong and for us to catch that error, right? So has anyone made like an Express app that uses some SQL before? If you've, can you raise your hand if you've made an Express app that uses SQL before? Great, cool. So imagine somebody's signing up, right? And they're putting in their first name and their last name and their email, and they leave their last name blank, and they hit submit, and your HTTP server says, okay, take their first name, last name, and their email and send it to this SQL query where we're going to do insert into users, set first name, last name, email, and then we put in the data that they gave us, right? But our database has a validation error that says you can't have a blank last name. It's got to be at least one character, right? So we get some information, we send it to the SQL server. The SQL server says, I'm not going to insert that because it violates our constraints. So that's going to raise an error, and we're going to catch that error, and we're going to say, oh, okay, this didn't work. Let's respond to the user. Well, we're going to render that sign-up page again with an error at the top that says your last name can't be blank, right? So that's an example of us giving foreign, unknown, unreliable information to part of our program, and then our program is designed to reject invalid information by raising an error, and we're going to catch that error, and we're going to rescue from it by responding appropriately with you gave us bad information. Yes. We could do it with an if statement for sure. But the reason why we want errors is because when we're running our program, right, we've got, and again, this is all within the context of synchronous code. If we're going to do this with asynchronous code, it's handled a little bit differently. But in synchronous code, we do we do work that is sequential, right? That's not what anybody wants, right? So these are the steps of our program. What we can do is our program will execute, and let's say we've got, let's imagine this is like the thing that called the function, right? So something up here called do work, and do work is going to do A, B, C, D, E, and F, and then be done, right? And if in the middle C has a problem, step C has a problem, the reason why errors are nice is because you can throw an error here, which will prevent the rest of this code from happening, and the code that called it can intercept that error. So normally we would go through the sequence, and there's no way other than throwing an error to say abort, skip what's left to do, there was a problem, don't do anything else, right? We could do like a return if we wanted to do something like that, but the reason why we want to throw an error is because we have functions that call functions that call functions that call functions, and when you're down a tree of function calls, you want to be able to say abort everything, abort what I know I need to do left, abort whatever called me thinks they need to do left. There was a critical problem, and it throws an error. And when it throws an error, that error goes from where it was thrown to the function that called it and looks to see if it's in a try-catch, and if it is, you can handle it. If there's no try-catch, we go up the call stack again to the function that called that. And if there's a try-catch, we can handle it. If not, we go all the way up, and if we never encounter a try-catch, a throw will go all the way to the top of the program and stop the program from running. So if we're running a node application that's a web server and someone signs up with some bad information, we don't want the whole web server to shut down, right? We don't want our program to stop. So we need a mechanism by which to say, normally we would do A, B, C, D, E, and F, but C failed, so cancel everything until, and raise an error until there's some code that explicitly says, if there's an error in this process, I know how to rescue from it. I know how to handle it.
So Jared, are you saying that if you used it in an if statement, it would do what you were saying, you would go back up, back up, back up? It wouldn't abort?
Say that, ask me again, sorry.
So the question was like, why couldn't you just handle it in an if statement? And you're saying if we handled it in an if statement, it would be the worst case scenario of what you were just explaining.
Well, I'll try to draw you a more detailed call stack here, right? So let's say we have the thing that handles this is the sign up route function, right? And it's going to call the create user function, which this thing's going to call the insert into users table function, and then maybe it's going to call like an insert into like an update total user count somewhere in the database or whatever, and then maybe send welcome email to the new user, right? So if this is our workflow, right, the sign up route gets information, it calls the create user function, which calls this function, which then when it's done calls this function, right? We could put an if statement somewhere in here that would stop what was happening. But if I'm down nested inside of here, so maybe in here there's some sort of like SQL query generator that we're using that's used in both of these things, right? So if inside the SQL query generator there's an error, like you gave us a string for a field and it should be a number and it's not valid or something, this thing can throw an error which allows the calling function to catch and rescue from it if it knows how, if it's programmed to do that. If it's not, then it bubbles up to the create user, ignoring what's going to happen later, disabling that from being the next part of our program or changing the flow of our program. So this is, in some sense, error handling flow control is often what it's called. And so create user can say, oh, was there a SQL query generation error? If that was the case, now I know what error to report back to the user, so I can rescue from that error, my program's not going to exit, and I can return, I can render a web page with an error, right? So it allows this, like, as we're walking down this complex tree of a call stack where we go into functions and back out, and we're jumping all around, we can say at any point in our program, abort whatever's happening next, wherever that is, and rescue it, and go to the code that knows how to rescue from this error if there is any. Right. So yes.
So this is with try and catch. Is what we're talking
Uh-huh.
about. And so catch allows you to like stop the program, not like complete the rest of the.
It's the throwing that stops from going to the next step. It's the catching that stops the thrown error from getting to the top of the program and being caught by the highest level catch, which will stop the program.
So that is what I don't understand.
Right. Okay. So let's do an example of this.
Every time you get an error, it stops your program.
Every time an error is thrown, if it's not caught by something, it will stop the node process. This isn't true in a browser. Browsers work differently. If there's an error that's thrown and it's not caught, it just gets logged in the console, and then that's it. And you keep going. So it's different in browsers. But in Node, if an error does not get caught, it'll eventually be printed and close the program. Yeah? So how does the catching part work? So let's try this. Let's do this. So let's say we're going to use fs read file. Read, my brain. Oh my God. Okay, so we're going to try and read the file, whatever.json, right? So let's make a function here called get state. This is going to get the state of our program. So actually, we'll call this state.json. This is much like the 3-2-1 context where we're reading a JSON file, even more so like the to-do list where we're reading and writing to a JSON file. So this is going to just call get state, and then we're going to have another thing called write state, which is going to use the synchronous write file to update the state here, and maybe we'll turn it into, we'll do it, yeah, we'll do that. Okay. For where?
Line 4.
Oh, thank you. Cool. So when our program runs, we're going to say read the state, and then we're just going to log that. Okay? Does this program make sense as an example? Anybody got questions about what's going on here? Sweet. So node state's already been declared. I knew I didn't need that. Okay, so we run this, and that's not what I expected. Oh, because it's not read state, and I never ran the run function. And it's not read state, it's get state, and I'm going to call this set state. Cool. So here we get an error, unexpected U in JSON. So this is coming from line 5. So we got an error parsing this. What does this thing say? I expected fsReadFile to throw an error because state.json is not a file. So what does this say? I don't think so. Like that, you mean?
Oh, yeah.
You write it what? Without a dash? Huh, okay. Oh, I mean read file sync, that's why, thank you. Right, because we're talking about synchronous error flow control, so I don't think we need this. And great. Okay, so great. No such file or directory. That's the error that we get, right? So we want our program to be able to say, we tried to read the state and we got this error, so we need to initialize our initial state, right? So one way we can do that is by saying, we're going to turn this into a let, and then we're going to say, try to get the state. And if there was an error, we're going to run state equals initialize state. Which will just say call, we'll create the state of our program, I don't know, things as an array, right? And then we will say return state, and we're going to say set state to that state. So I'm going to run this, and now we have state things, and it created state.json and put that in there. So we actually got an error because we tried to read our state and the file didn't exist. We caught that error, and we probably should have looked at it to see what kind of error it was, because we might want to handle different errors for different reasons. But we're just saying if we get any error reading the state, then we're just going to reinitialize the state and write that file. And now the next time our program runs, so here, I'll put a log here that said error reading state. And here was the error. So I'm going to remove the state JSON and run our program again. And it says error getting state, and here's the error. But then we keep going, and we actually initialize the state, write the file, and it keeps moving forward. So where our program normally would have aborted, would have failed, because there was an error raised by this function here, we're able to rescue from that error. So you can see that get state threw it somewhere deep inside of read file sync, and if we look at the backtrace here, we can see that here's our code. We called get state, which called fs read file sync, which called fs open sync, and open sync threw an error, which then got sent back to read file sync, who did not try to catch that error. So it got thrown back up the call stack again to our code here, line 4, where we also did not try to rescue from that error. So that error goes up the call stack again, back to line 24, where we do catch that error. And then we decide to do something else, and our program is rescued from that problem, and we can continue moving forward. Does that clarify things?
Sort of, but I did see where you used throw.
I did not use throw. So throw happened because this is common amongst many tools in Node, that if there's an error, it's going to throw an error, right? So here's another case where an error would get thrown, and I'll use throw in a second, but I want to illustrate that a lot of these functions are going to throw errors. So it's not always us throwing errors, it's that errors get thrown, right? So JSON parse can also throw an error. So let's say we read the file successfully, right? But I'm going to go into state.things and I'm going to break our JSON. That's invalid JSON, right? So when we run our program again, we get error getting state, syntax error, unexpected end of JSON input. But our program was like, okay, whatever, there was an error reading state, and we'll just reinitialize it. Not the greatest way, but it's a good example of a program, right? So now we're getting an error thrown from JSON parse instead of read file sync. So that's an example of some tool we're using throwing an error and us rescuing from it. If we want to throw errors ourselves, we could do something like this. Here's another way we can do it. We could say if type of state is undefined, we can throw a new error, state cannot be undefined, right? So now we have made basically an argument validator for this method that will throw an error if you try to call set state and not give it a state. Does that make sense? So now down here, let's say we accidentally set state to undefined somehow, or we mess it up somehow, and then we call set state. You can see that our program is going to throw an error. State cannot be undefined, and our program has exited. I will put a thing down here that's like program ended successful, so that we can see we don't get to that, right? Because we didn't catch this error, right? We called set state with undefined. It got to here, it threw an error, and we didn't catch it. So one thing we could do, if this was something we could rescue from, because this came from this line of code, not up here. This was the thing that caused the error.
So that catch is only going to work within that block.
Absolutely. It's only going to catch errors that occur for code executed in this block. Yeah. Is that clear, Sabrina? Yeah. Cool. So if we thought that this was possible and we could rescue from it, right, then we could say try and catch, and then we could rescue from this however we can. I can't think of a good example of how we would rescue from this, but like you can imagine how we could rescue from this, right?
So when you say rescue from it, it means like don't stop the program, continue going.
Correct. If this error is something that I can rescue from, so let me get more specific here, right? So this error that comes from the state file not being there, the one that says no such file or directory in the error message. If I'm explicitly trying to rescue from that error, right? I'm gonna say if error.message includes, or some matching strategy, right? If it includes that, then this is how we're gonna rescue. Right? If that's the kind of error we got, we're gonna rescue by reinitializing the state, right? Else, we're just going to throw the error again because we caught it, we looked at it, we don't know how to solve this problem, so we throw it up. Right? So it's basically like whoever called us is responsible for handling our errors unless we know how to handle them, right? So if we get an error from something we had a delegate do, if we get that error and we know how to rescue from it, we can. If we don't, we throw it up, and maybe something more with more responsibility higher up the chain can handle that. Otherwise, it closes the program.
So I think I have a question. If you're going to use a throw, like a throw error in your code, and then like catch from that to rescue your program,
Yeah.
why not just try catch with no throw?
Well, in order to reach a catch, you have to throw. Like you can't get into these catch blocks without an error having been thrown.
So it's either you ran it in node and it threw an error, or you controlled the throw.
Like, how do you
No.
know the difference between what will automatically throw or what we have to throw?
It's no difference, right? If you're writing code where errors might occur, like this error, like someone called your function that you wrote with an invalid option, right? This is how you should report that to the folks who are using the code that's using your code, right? You shouldn't just return a string that says like you gave me bad information. A return implies that you did something successfully. If something unintentional happened, you should throw an error. So if I'm writing a module that someone else is going to use, and they use it incorrectly, it's appropriate for me to throw an error and say you used this incorrectly. Does that make sense? So for example, like JSON parse, if I use it incorrectly, right? If I give JSON parse in array, it's going to give me an error, I imagine.
But Jared, I thought I understood you saying that some things will throw automatically.
Yeah, so JSON parse will throw an error if I give it a bad value.
So how do we know what will throw an error or what we need to throw? Am I asking
I understand, yeah, sorry. So when you're using any library, you will encounter errors being thrown as you use that library, right? So if we start using JSON parse, I have no idea what errors it's going to throw until I encounter one, right? So this is why when I'm using a tool, you know, again, if I'm taking in some foreign string from somebody else and I'm going to pass it to JSON parse, I want to know what's going to happen when that string is wrong or bad or invalid in some sense. And so as a programmer, I'm going to play with those cases. I'm going to put in some, if it's possible for me to send an invalid thing, I'm going to do that to see what errors happen so that I can make sure to handle those cases, right? So for example, when I'm using the read file sync method, I'm going to actually try to use it on a file that doesn't exist and encounter that error because it's a case I'm aware of that might happen and I need to handle it, right? So we can't handle all cases all the time. We don't know everything that could possibly happen, but as programmers, we want to keep in mind, what's the ideal happy path? How's my program supposed to work when everything is in the right place? But what's going to happen when things aren't in the right place? What happens when someone deletes this file on accident? Does our program handle that kind of condition gracefully? And most of the time it doesn't, right? We're writing programs and we give them to people to use and they use it in unexpected ways. And they're like, hey, I deleted this file and now your program doesn't work and I don't know why. So we might go back in the next version of our program and say, okay, let's make this error message a little easier to read. Rather than throwing a file not found error, we'll throw your configuration file was not found error or something more specific, right? It's really just like when you find opportunities in your program where things are invalid, you should or unexpected, you should throw errors about them. And when you use a program that you know, an off-the-shelf tool, if you use it incorrectly, you're going to get errors.
That's the clarity. Okay, so we have to throw it if we're creating like the constant initialized state. That's something we're building.
Yeah.
So we have to throw if we think there might be an error.
Yes.
But if we're using read file sync or any other library,
Mm-hmm.
right, library,
Mm-hmm.
they're going to have their own built-in errors.
Yes.
We need to catch them.
Yes.
We don't have to throw.
You don't necessarily have to catch them, but if you want if it's possible for your program to save from that error, then yeah, you should catch them.
Okay, so I just need to reiterate that. So
Okay.
I can try to block code and I can catch the error whether my program threw it or I literally wrote this error.
Correct.
So, okay, so my last question
Yes.
is what is the difference between catch and finally?
Got it. So finally runs no matter what. Okay. So again, let's look at this example again, right? We're saying get state, and if there's an error, do this, but finally will happen regardless of whether or not an error was thrown.
I'm sorry.
Okay, let's get abstract for a second. Right, so in the case that there's no error thrown in steps A, B, and C, we just go to F and G. In the case that there is an error thrown in, say, B, we're only going to do A. B's going to throw an error. We're going to do D and E, and then always we do F and G. Finally, just always happens. So I rarely use finally, but it's definitely got its use cases. So here's a case at which, here's a common case at which we're going to do this. Okay, so sometimes we have like global variables set. There's a library called Chalk that will help you print out colorful text. It puts the right invisible characters to tell the terminal to change the color of text. But it has an option to just turn off colors all the time. So you can have your code using Chalk to say this should be red and this should be green, but then you can just set a global variable that's on this Chalk thing to just turn that off. So even though I'm using those red and green functions, they're transparently doing nothing. So I can just globally turn colors off on my whole program, right? So let's say to do that, we just say chalk.colors false, okay? So now I have a function that says, print enable colors. That's a higher order function that takes a call. It's not really a callback, but it takes another function. And so within my program, I'm doing things like this. So this is how you use Chalk, for example, right? So you just pass it through these functions and it sets them to, puts the right invisible characters to set the color, right? So if I set Chalk colors false, that means this is going to come out as not colorful, right? So I want to make this function where I can say, okay, this should be colors, colors on and off depending on what that variable is, but sometimes I want to forcibly enable colors, so I'll do something like this, where I wrap this code in, I give this function to this other function, which is going to do this. It's going to say, temporarily turn colors on, run the function, and then we're going to put colors back to whatever it was before. So does this make sense?
Yeah.
This might be too convoluted of an example, but so colors is off, so this is not going to come out colorful, but when I put code inside of this enable colors function as a callback, it means turn the colors on, call the function, turn the colors off. Or not just turn them off, but put it back to what it was before. So if they're on, this will keep them on, and if it was off, it'll put it back. It doesn't know, it just remembers at the time. So the problem with this kind of thing, which is a pattern that's used a decent amount, but the problem with this is if there's an error in here, right? So I forget this plus or something, this is going to throw an error. And then this is never going to happen. So this is going to cause a bug where colors were off. We ran this function to temporarily turn them on. There was an error in the callback. And so it broke the enable colors because it wasn't able to turn that stuff back on, right? So what you want to do is you say, okay, whatever happens in your code, I don't care. I'm going to catch that error, and I'm going to rethrow it. But it gives me the opportunity to say, no matter if there was an error or not, make sure you always do this.
Okay.
So the error still gets thrown. So in my program, if I run this code and it's got this syntax error in it, it's going to work as expected. It's still going to ensure that colors were restored to the option they were, because this finally will get called even if I throw here. Cool. Yes.
So earlier you were saying, well, you're getting a recall sync. If you're doing the read file, if it's asynchronous, would you not?
So asynchronous error handling is different than try-catch, because try-catch only works in a single loop of the JavaScript event loop. Try-catch just wouldn't work for a synchronous function. And the reason it doesn't work is because, I mean, almost all functions, synchronous or not, have some code that they do in the current thread, in the current loop iteration, but then they put something on the event loop and the JavaScript like stack of work to do that happens in another thread. So even if I put a try-catch block on it, I'm going to do the try. I'm going to call read file sync, which gives it a callback and schedules some work to be done. And then that catch block is done, and I keep going in my program. And later it comes back around and says, oh, I tried to read that file, and here was the error. And so there's nowhere for it to throw. So what it does is it calls your callback, giving you the error, right? So that's the big difference, right? We don't use try-catch. We use either looking with an if statement to see, did my callback get given an error? Or if we're using promises, that we use the catch block in promises, which is a special kind of catch. It's not the same. So, yeah. Try-catch is for synchronous code, and promises is for asynchronous code. Cool. Is that enough on try-catch?
This was a really good example.
Cool.
For me, at least.
Great.
I think the only question I have is, and I think I just have to use it to like learn this, but when you're using finally, and I get that it happens usually regardless if you're using finally or not, it's what you usually I guess, but with the exception of this example, right? Because in this example, we're like overriding the program stopping because we threw an error, right?
Which part are you pointing at?
So in this, the chop example.
Uh-huh.
So when we say, hey, no matter if you get an error here or not, please go ahead and
Do this either way.
Either way.
Yeah.
Are we overriding what would normally happen?
No.
And I mean, like, are we overriding the program stop?
Well, not through finally. The program isn't stopped because we caught, well, in this case, we're not overriding the program stopping because I'm rethrowing the error. So now it's up to whoever called me and up the call stack, which I'm blind to, right, to handle that error, or the program will stop. From the perspective of these functions, you have to think about each function is being isolated from who called it. You don't know anything about who asked you to do the work. You can either just return or throw an error. It's your only recourse for a response to being called. I mean, other than like modifying global variables, and that's a complicated way to affect global state and all that stuff, let's talk about just like simple pure functions. You can raise an error or you can return. And returning implies some amount of success, some kind of success, yeah. Synchronous code is, a for loop would be a synchronous would be some synchronous code for sure, yeah.
I'm more familiar with doing asynchronous code, but I haven't really been exposed to like synchronous code other than like loops and stuff.
Sure, I mean, you can't be familiar with asynchronous code without being familiar with synchronous code, right? Because synchronous code is a foundation for which asynchronous code is built on top of, right? Are you saying that are you saying you have what you just said because you're not, it's more clear how to handle errors asynchronously than it is for you to handle errors synchronously? Okay. I mean, built of a pile of little synchronous steps, right? So we need to be able to handle errors synchronously as much as we need to be able to handle them asynchronously. So it's important to know both. Is there some clarification you're asking for?
Usually when I'm unsure about things, I'm unsure what to ask as well.
Okay.
Yeah. So
Okay.
it's okay.
Cool. Well, I guarantee you, you're going to write programs and they're going to throw errors, and you're going to have to deal with those errors. So yeah, try catch is if you're getting an error in your program and your program can be smart enough to rescue from that error and it's appropriate to the problem, try catch is going to be the way to do it for synchronous code. And then if we're doing asynchronous code, hopefully we're using promises. But either way, callbacks or promises, we want to make sure that we're always keeping in mind every step we do could fail. Now that doesn't mean wrap everything in a try catch, but in the cases where you're like, I know this could happen and I know I'm going to get this error, you should use try catch or promises catch to handle that.
And is the natural flow, if you want to do a finally, you have to do a try catch throw finally, or can you do a try catch finally?
Oh, what you do in here is irrelevant. Try, catch, finally has to go in that order, I believe.
Yeah.
You might be able to, I don't think you can do a try finally.
Well, I don't think you can either, but you can do a try catch finally. You don't have to do throw.
You do not have to throw.
Okay, cool.
Yeah, you have to catch. Look at that. That even happened after. Yeah.
I was going to say something about testing.
Another question?
No, not a question. It's more like just I didn't realize that the job that I interviewed for was for a testing position, because a lot of companies like to hire, I guess this company in particular, like to hire juniors as people that would write tests for all their different applications and stuff.
Sure.
Like this shit's
Sure.
really important.
Sure.
And I
Yeah.
really like underestimated the importance of it, I guess.
Yeah.
Just like different terminology behind it too.
Yeah. I think that try and catch is an essential part of flow control in any program. So, yeah. Whether or not you're getting that job, that kind of initial entry-level job where you're just doing tests, which sounds horrible, but it's useful knowledge. Yeah, writing tests is really important. All right, let's move on to some of the other stuff we have. We spent 45 minutes on this one. Yeah, no, don't be sorry. Okay, great. Call versus apply. I'm going to do this pretty quick. Not Apple. Okay, so let's say we have a function. Let's just look at console log as a function, right? If I console log 1, 2, 3 versus the array 1, 2, 3, this is the difference that I get, right? So let's say I've got an array of things I want to log. And I don't want to log them as an array. I want to log them. This is just an arbitrary example. Think of this as, I'm using log as an example of a function that can take an arbitrary amount of arguments. It could take an array, or it could take, 10 arguments or whatever, right? So if you have a function that takes some arguments that have to be broken out like this, you can't just give them an array, but you're collecting them in an array. So I can do this, but there's really no way for me to I'd have to manually do something like that if I wanted to get to this kind of thing, right? So I'm looking for this kind of log. This is not what I want. So how can I call log and say all your arguments are the things that are in this array? And so in modern JavaScript, I think you can do the splat operator. right? So this is new, and I'm not even sure whether it's supported in most browsers, but this is new to JavaScript. We didn't used to have this before. So the only way we used to be able to do this, does that blow your mind or something? Oh, okay. So the way we had to do this before was with apply. So call and apply are functions, they're methods on functions, right? So console log has a call method and it has an apply method. And the way that they work is they both take a new value of this. They say, so in this case, I'm going to put console here. But in the call syntax, it takes the first argument is the value of this, and every subsequent argument is the arguments for the function. Apply is a little bit different, where you give it an array, and the array represents the arguments that the function will be called. So if we look at this code here, we see the same thing here. Okay? So when I call console log, you might remember from your studying of how this works in JavaScript. If you call a function, the value of this is the object that was before the dot when you called it, right? Whereas if I did something like this and called log, now the value of this in this instance is the global object or undefined, depending on if I'm using strict or not, right? So call and apply are used to, in some cases, to specify the value of this explicitly, right? So I can come down here and I can say, okay, log.call on the console object, so that's the value of this, and then here are the arguments, right? But I can also use call and apply like I'm doing here, where it's like, okay, the value of this would have been console anyway. I'm not getting anything by using console or using call and apply here. What I'm getting is the ability to do this. So if I want to give console an array of things, because I didn't always have access to the splat, instead of the splat here, I'd have to do something like this. Instead of the spread operator. Splat's probably the name for the Ruby same version. If you've read it as spread, you're probably right. Cool. And that makes more sense, right? It spreads it out through the arguments, right? So that's what apply is doing here. Yes. Bind gives you an intermediary function, right? So if I wanted, like, if I was going to do this, I probably wouldn't get a copy of log that wasn't bound to the console object. So you could do like this, and now you've got a new function that is something like this. Right? It's a wrapper around the log function, binding it to console, right? So instead of having log on its own, I actually have a different function that when called will call log bound to console as the this function, or as the this object. So bind is when you want a function that is bound, that you're going to use maybe more than once, or you need to have as an object. But we don't care about getting a copy of log that's bound to console in this case. We're just using apply for the spread nature of it. So bind isn't going to do the spread for you. Bind is going to give you a new function that binds a function to a specific value of this. And we do less of that now that we have the arrow function. Because the arrow function inherits the value of this. Lexically, yeah. It's like an auto-bound function, yeah. Yeah. Cool. Is this clarifying things for who asked about bind?
Yeah, I mean, my question was really just because call and apply, they return the same result.
They don't return the same result. They call the function in almost the same way, right? The difference, these are the two differences, right?
Yeah. But that's is assuming that the arguments that you're passing are the same as the individual elements.
Sure, it's just dangerous to say that it returns the same thing because call and apply's return value is not up to call and apply. It's the return value of the function being called, right? So it's it's a nomenclature thing. I think you have the right idea. It's just call and apply's only responsibility is to call a function in a specific way. It in no way determines the return value except implicitly by what you passed in, right? It's cool. So they're exactly the same except they just take arguments a little bit different.
Yeah, so I was just wondering, like, does it make a difference then whether you use call or apply?
Only in how you give it the arguments.
Yeah, so in that case, like, assuming you know all the arguments, it's just a personal preference whether I want to
No. It's not whether or not you know all the arguments. It's whether or not you're dynamically creating the arguments in an array or whether you can explicitly write them out. You can't always say, call this function with A, B, and C. Sometimes you have to collect A, B, and C in an array. You don't know that it's only 3. It could be any number of arguments, right? So if I need to call a function with an unknown number of arguments and an unknown set of values, and I'm programmatically deciding what those things are, I have to use the spread operator or apply to be able to take that dynamically generated array and spread it out into the arguments of a function. So that's the only reason I would use apply. If I know the arguments and I know I'm going to be passing A, B, and C, I'll use call because I can literally write A, comma, B, comma, C, right? Yeah, that's the difference. Yeah. All right. I don't have time to do Flexbox, but I can explain these two things. Caching is an extremely general term. There's no specific example of what caching is, but in general, caching is whenever you have some expensive calculation or derivation of data and you don't want to have to pay that cost every time someone wants a copy of that information. So for example, let's say you have a blog and you have the homepage for your blog, and in order to generate the HTML for the homepage for your blog, you have to ask the database, what blog posts do I have? What are their titles? What's the first paragraph of the body or whatever? And so we do the database query and we get that data back and we use a template to create a bunch of HTML, and that's what we'll show you when anyone comes to the homepage of your blog. But let's say you've got millions of people coming to your homepage. We don't want to have to query the database and turn that into HTML for every single million hits, every single hit that we get. So what we'll do is we'll say every time someone comes to the homepage, do that work and then store that resulting HTML in a cache somewhere. Huh? It's like a temporary snapshot save point, right? So we're going to cache that. So the next 999,000 people that come, they're going to get a fast experience because they're just getting this cached version. And maybe it's a little bit out of date. Maybe you published a new blog a couple seconds ago, but that cache has a time to live, right? So maybe it's okay for you to publish your blog and it takes 30 seconds for it to show up on the homepage because we only recalculate what the homepage is every 30 seconds, right? So it's that's one form of caching. But caching really is just any time you've got, again, an expensive calculation or rendering of some information, and you can't afford to do that every time someone asks for that information. So the web has caching built in, where you can tell a browser, if a browser asks you for an image or any resource at all, in the headers, you can say, here's the image, this will not change for an hour. This will not change for a month. So when the browser, you do a Command R and the browser reloads, you'll see in the console, you get like a 304 content not modified or something like that. And you'll see it came from cache, right? So you can see this if you look in the network panel. If I go to just images here and we reload the page, I don't have disable cache turned on. From memory cache. This photo, we did not make a request. It was from memory cache. So speed. That's how your web browser feels a little faster at times, is because the websites are saying the logo for Amazon, that ain't going to change in the next month. So just cache that. Never, don't ask me again. You have that. Keep it in your cache, right? Cool. All right. And then the package lock file, all you need to know about that is that, well, you need to know to commit it. But if you look at like, so let's look at the curriculum apps package files. Nope. It's just a file, just like package.json. You need to commit that. It's important part of your program, right? So if we look at the curriculum app, here are the dependencies of the curriculum app. I use Pug. So this thing says, anytime you see this caret, this is a very specific version expression. There's actually some stuff to know here. You should look at NPM, and they talk about the syntax for what this means, right? What does the caret mean? What do these dots mean? And if I remember correctly, the caret means you can use any version of these libraries, marked, connects, or whatever, where this can be anything you want. The last dot you put here, that's the range that's okay. Any 0.3 point anything is okay for you to use for this application. That's what this expression means. And so sometimes there'll be a bug where I'm developing a feature and it works on my machine, and that's because my machine is using marked 0.3.7, okay? I think it has to be at least higher. It has to be anything higher than the last point of specificity listed here. If I did this, it's anything higher, anything 0.3 or higher. This is anything 0.3.6 or higher, but not higher than 0.3. Does that make sense? Right, so we can only go up from this number past the last dot, is another way to say it. So on my machine, I might have 0.36 installed. And then I go to install it on Heroku for production, and I'm going to run it somewhere else. Or you're developing a feature on your machine, and you're going to do a fresh install. If 0.3.7 is out, Mark's going to install that, because that's the latest version, and it meets our constraints here, right? So now my feature works on my machine, but it doesn't work on yours, because something's different about marked 0.3.6 than 0.3.7. That generally shouldn't be the case, but sometimes it is. So now we have bugs that I can't fix here because I have to track down that the bug is actually because we're on different versions of this thing, right? So one way to solve this is to not have this ambiguity in our dependency expression, right? We want to say this application was built for marked 0.36, only that version, don't install anything else, right? And I think you can come in here and do that, but the overall solution, so NPM had this issue where companies like Facebook were deploying their application all over, and they were getting slight version differences in their dependencies, and it was causing a bunch of headaches. So they made this thing called Yarn, which basically was an alternate NPM, or at least it wrapped around NPM, and it wrote this yarn.lock file, which took your dependencies and turned them into explicit, unambiguous, locked versions for each thing, okay? And we're not just talking about dependencies, we're talking about dependencies of dependencies of dependencies. So there's this big tree, it's real complicated, right? So NPM was like, great, this is a feature that we totally understand the value of. There shouldn't need to be a third-party tool for this. So they very quickly added it to NPM, where now if you want this, or I guess even if you don't, you get this package.lock file, which comes in here and says, marked, you are 0.36 unambiguously. And if you had any dependencies, we're going to lock those too. So there's a bunch of stuff in here, like here we go, Mocha has a dependency on Commander. And so maybe Mocha says, I don't care which version of Commander we use, 0.9 point anything's good for me. We don't want that ambiguity. So we're even imposing stricter dependency regulations or definitions on the dependencies of our dependencies, right? So this file allows you, is NPM's new feature locking you to specific versions. And so you want to check that in because you want that feature. Cool.
So I've heard of Yarn and NPM sort of like the same.
Yarn wraps around NPM. I don't think we need to use Yarn anymore. It's an added tool that I think NPM is trying to pull in those features and make them part of NPM. So I don't think we need to use Yarn anymore. I'm probably I'm sure plenty of blog posts will disagree with me on that, but that's my impression of the state of version control or dependency control in Node. Cool. Thanks, everybody.
Chickpea?
No, thank you.
Just like throw your bothering